I'm Earl Mallia. I'm a landscape and astrophotographer. Today we're going to talk about wide field astrophotos and deep sky astrophotography. I've been shooting now quite a while, wide field astrophotos and astrophotography. It's been almost 2 years and a half. Back in 2018, after a year, I bought my first star tracker, and it opened a whole new photography in deep sky astrophotos. Today, apart of showing my work, I will discuss some of my equipment and some other techniques that I use to capture the night sky. As the Milky Way season has started, I think it will be more interested to try to take some shots of the Milky Way galaxy. So these are basically some equipment that I carry around while shooting wide field astrophotography and astrophotography, deep sky astrophotography. I own 3 body cameras. I own a 5D Mark III, an 80D, and a 550D Astral Modified. I will explain later what is Astral Modification and what it does, the Astral Modification. I own several lenses, and I own most of them prime lenses, as I believe in fixed apertures. And obviously, prime lenses, they let certain light, because they have fixed apertures, to let in, so you can lower your ISO and you will end up with cleaner images. I use a Benro True Night filter. The True Night filter, what it does, it will eliminate some of the air glow that Malta, especially Malta, is surrounded by light pollution. I own 2 sturdy tripods. Basically, I use for astrophotography the one on the right over here, the big one. It's a very sturdy tripod, and I believe that a sturdy tripod is very necessary for this type of photography. Etilopa bag, it's an f-stop bag. It's I'm really happy I recently bought it. It is a hiking, mountaineering actually bag that basically it is for cameras, but it will let you to put more stuff in it. So as when I go shooting at night, basically I will go shoot deep sky astrophotos. It not will take me more than 1 hour. Sometimes I'll to go at home satisfied with my photos. It will take me 5 hours and to get a decent result. I own a star tracker too, a star adventurer. It's from Skywatcher, and a La Creta super auto guider that is over here. This is a small camera that I attach with my camera. I will explain more later what it does basically for astrophotography. Another thing with the Astral Modification of the 550D, I have a special filter. It's the IDAS filter. It's a light pollution filter, but it's dedicated for astronomy. What it does is it eliminates completely light pollution, but it lets several wavelengths to pass, like hydrogen alpha. I will explain, but later what these things does. And obviously, an intervalometer, a shutter release cable, it does a pretty good job, but I prefer an intervalometer because I can set the timer and I'll just stay relaxed. So what do you need to look before buying a lens for astrophotography? As I said before, I think And if the key factor is luminosity. So that's why I prefer prime lenses. It's important that it is an f2.8 lens or lower. Here over here, I wrote, if you're shooting with a star tracker, it doesn't matter that much, because the truth, when I shoot deep sky astrophotography, because I have compensation time with the star tracker, basically I shoot 5.6 f4 because I want my actual photos become more sharper. So that doesn't matter that much. But if you're shooting on a tripod, it needs to be a lower aperture for sure, f2.8 or lower. Regarding the focal length, it doesn't matter. Basically, I prefer such focal lengths starting from 24 because that's my opinion. Because I think if I go lower than 24, if I'm shooting the Milky Way galaxy, it will become smaller in my frame. So I prefer even the distortion. I prefer 24 because 24 I see it like, it's truly the frame. There's not that much distortion even. So you have to consider another thing before buying a lens for astrophotos, for wide field astrophotography, or for deep sky astrophotos. And this is the most important thing that it really annoys me at first. It's the coma and the distortion of the lens. Basically, here are two comparisons, and I wanted to explain basically why this occur. And here you have a lens of a DSLR, of a camera body, and the telescope. So this happens because basically any lens for photography, it's not made for astrophotography. And that is why, because these distortions comes because of the elements. Basically, the elements on a lens, they are rounded. And another thing is, there is a lot of lenses. Nowadays, they make 8 elements on a lens, with coatings and stuff like that. So those are made for photography, not for shooting stars. And these happen about of those things. In fact, if you can see the diagram, a telescope refractor, a telescope imaging, it has only 2 objectives. And that's what makes the difference. So these are very important when you choose a lens for astrophotography. Nowadays, lenses improved a lot. So the concern about it's everybody concerned. These big companies of lenses, they know that these lenses had problems about, so they fixed. Nowadays the lenses are pretty good. But I wanted to make a comparison of the Samyang 14mm over here on the left hand side and the Canon 14mm. You can see the middle, it's always right. The problem is in the corners. In fact, this distortion and coma makes the image not pleasant. Let's say not pleasant. And the 24 to the Samyang 24 and the Canon 24mm, you can see the difference. In fact, I have to say that Samyang, they do a good job on doing lenses. They are manually focused lenses. So for me, for astrophotos, doesn't matter basically, but they are really good quality lenses. So I own two of them, and I'm pretty happy with them. I own the 24mm and I own the 14mm. So I listed some lenses over here that basically these are made for DSLR because I'm still shooting with DSLR, not with mirrorless. So I can say that today's mirrorless are more noiseless free and more convenient than DSLRs. But I have three bodies, so it's difficult now to switch if something occurs, and I'll switch to mirrorless. But for now, I'm shooting with a DSLR. So these lenses are for DSLR. And if you can see, they are all pretty decent prices and all fixed apertures. So the Tamron 15 to 30 f2.8, it is very sharp for full frame sensors. And it's fixed from 15 to 30. Basically, I don't own that, but I have a friend that he owns that, and I borrowed it for a couple of minutes to try it, and it's very, very good. I own the 14 and the 24, as I told you, some young, and from the APS-C section, I own the 11 to 20. I have an old version than that. It's the 11 to 16, but I try to buy my lenses on fixed aperture basis. So, which best time to photograph the Milky Way? Basically, it's the whole year. The Milky Way stays the whole year in the sky, but the core appears from March till October. Let's say October, till the end of March and October. Those periods of times, they are the best to shoot the core of the Milky Way. The best time to shoot the Milky Way, actually in Malta, it's between June and September, because the core it's more visible. Because I went to shoot the Milky Way in March, I had to wake up at 2:30 in the morning, so it's not that convenient. But the Milky Way season had started. It started in March, and you have to be careful where to go to shoot it, because if you can see the graph over here underneath, there's a lot of light pollution. The blue section are where there's less light pollution. So obviously these the southern part, these blue, you have to be concerned on that. So something else that I want to explain is how I plan my shots. There is an application, it's called Photopills, that it will give you. Basically, it's made for landscape and for tracking the Milky Way. Basically, it's a simple application. It's a mobile application that here I describe that it will gives you the visibility of the Milky Way. Here you can see there's the dots over here, and the dots, they are the galactic center elevation. So you can see where's the core is going to be and at that right moment. And obviously over here, these lines, one can see when is going to be visible. So this application, it's complex because it has different usability. In fact, these lines over here, these are when the sun rises and actually the sun sets. So it is very versatile, the application. But today we're talking about Milky Way. So if you can see here, these lines occur when the Milky Way will rise above the horizon. And here, these big dots, they will indicate the Milky Way core. So with these adjustments, you can plan your shots where you're going to go to shoot and plan the Milky Way. It's I think it's a €10 application, but it's a very good application. It's a time saver application, and you can see on the left hand side, you can see the moon phases. So you can plan more easily your shots because you say, all right, it's a new moon, or the moon is not going to appear at that time. So it is a very time saver application. Another thing to keep in mind, the 500 rule. To photograph the stars, apart of being in a sturdy tripod with an intervalometer to not touch the camera, and all things set up sturdy, you need to think in your mind basically that the Earth moves, so there's the motion. So the 500 rule, what it does, it's an equation that determines the result of the maximum time aperture to set your shutter speed on your camera. If, for example, you're shooting with 50 millimeter for a 30 seconds long exposure, you will end up with star trails. So this equation, it works out your shutter, how much you set it. For example, there's an example. If you're shooting with a 14 millimeter with an f2.8 aperture, it will gives you a 35-second exposure time. And if you're shooting with a 24 millimeter at 1.4, it will give you 20 seconds. What you will do basically, you'll divide. There's the 500. You need to divide it by the focal length, what you're shooting with. For APS-C, I consider that you'll divide it by 300. If you use this formula, basically you will end up with sharp rounded stars. When I use this type of formula, I never get star trailing or stuff like that. So I'm in the safe zone. Basically, what I do, if the formula works out 20 seconds, I give 15 seconds. So I'll make sure that I will not get star trailing on my shots. So these are some shots that I took in 2018, and 2018. Yeah, they are processed with the stacking technique. So I will explain more what the stacking technique is. These are some shots that I took in 2019. So what I did with these photos, basically the one of the chapel, because of the chapel, it was too much illuminated. I had to composite the image. So first, what I did, I exposed for the chapel. basically it was like bracketing. But obviously, I had to lower my exposure a lot to bring the detail in the chapel. And then I shot the Milky Way with higher exposure to bring out the details of the Milky Way. So these are stacking softwares. I use Mac, so I use the one on the left-hand side. But these are stacking softwares, and you can see how it improves your workflow in noise reduction. So who's using Mac, there's an application that is Stereo Landscape Stacker, basically. That one that I use, and I'll basically, it's really convenient. I cannot manage, I cannot imagine that I don't stack my images. If you can see over here, it's a single file, and stacked, it's zoomed at 100%, by the way. So you can see a lot of big difference. The windows, it's the same like the Stereo Landscape Stacker. These programs, they'll work up. You load your files, the actual files that you shot, and they'll stack. They are dedicated. They are not add-ons for Photoshop. They are dedicated separate program than Photoshop. So I'll make it clear. You cannot make an action or an add-on on Photoshop. So first, what I do is I put my photos on this program, and then I process it after on Photoshop. This Stereo Landscape Stacker, it's like Sequator. So what it does too, because you're shooting in high ISO, when I shoot, my average ISO is 3200. The noise becomes so random that not only in the sky I'll have noise, I will have noise in the foreground too. So that's not a problem for this kind of programs, because they will reduce the noise in the foreground too. So that's these are very convenient and time savers, let's say time savers programs. So this is actually a panorama, a vertical panorama shot at Maria Caves. What I want to, on the right hand side, what I want to just let you to see the comparison. I use the Benro True Night filter that I was talking about before. What it does, it cuts, if you can see, it cuts the light pollution, the air glow, and it makes the Milky Way or the stars more popping out. Because here in Malta, everybody knows light pollution, it's incredible. So it's impossible to eliminate all light pollution, but this kind of filter, this True Night filter from Benro, it will help you to obviously eliminate a bit of the light pollution. And obviously the image turns out a bit of a magenta, but that is corrected obviously in Photoshop. It's easy to correct the white balance. So this is basically the panorama, how I took it. I try to take my panoramas 50% into the frame. So it will be more easy in Photoshop. I stack with Photoshop. I used to stack with another program. It's Autopano Giga. It's a very good program actually, but Photoshop nowadays, they upgrade the panorama section, the panorama. They had bugs before, and but nowadays I prefer to stick with panorama or with Photoshop. Photoshop than other programs. I feel comfortable working more with Photoshops. And obviously, finally, I ended up, after processing it, with this final image. So everyone wants to ask a question or something?
Okay, you can all ask. Just put on your mics if you want to ask something to Earl.
Earl, that's Tony again.
Tell me, Tony.
How long, from experience for you, does it take you to plan a photo, a shoot? The planning you do before, you go for it.
Depends the location where it is. So, for example, if I have in mind to shoot, for example, the chapel of Haddingley, let's say I'm planning it now for August, for example. It depends what you want to shoot and where is the location.
So like you have to travel, forget COVID for the time being. You have to travel abroad. It's different too. It's a totally different case than where you're used to in Malta.
If you're traveling abroad, there is, I try, it's not a secret, but I will reveal what I do. If I'm going, for example, I don't know, the Dolomiti, for example, and I want to shoot the Milky Way in front of the Traceme, for example, what I do is there's Google Earth, and that gives you the exact elevation and everything. So what I do, I enter Google Earth. So I'll get the coordinates and everything, the elevation and everything, and I'll try to put them on Photopills. And then actually I have the not exact, but a good idea where the Milky Way is going to rise.
It's very good.
So it's not complicated, but
you have to know what you're doing. Yeah, you have to know.
You're never going to be exact, but you will have a good idea.
Okay, thank you so much.
Earl, when you are focusing manually, are you doing it sort of through your eyes, or else you go on infinity or a certain mark on the barrel of the lens?
No, I never go on the barrel because the barrel sometimes is not correct. So what I do, especially I go live focus. I turn my camera live focus, obviously on manual, and I try to make the stars point as can be. So that's my technique.
So you're actually through your eyes, looking at the monitor.
Yes. There is something else. That it will help, but not on wide lenses. On such focal length lenses like 300 millimeter, 400 millimeter, or more, it's like a filter. It's called a Bahtinov mask. This is used on telescopes, basically. It will cross the stars. And when it gets exactly crossed, you will be sharp. I have one on my 300 millimeter, basically. It is very, but on wider lenses like 14, 24, it's not.
Doesn't work well.
Doesn't work well because the stars are small. So you have to work with your eyes. Or what you can do is you focus your lens at the farthest object you can see, and obviously you don't touch the focus, and you go shoot at night.
Okay, thank you.
Welcome.
All right, Malta, you can continue. Well, there doesn't seem to be more questions.
All right.
So you can continue your presentation. Thanks.
Thank you. So now we're going to talk about more deep sky astrophotography and what it does, what you need to actually shoot deep sky astrophotography. So this is the star tracker, what I own. Basically, it's a Sky Watcher, Star Adventurer. It has a payload, so I can mount on it 5 kilos, and that's why I bought this kind of star trackers, because in the market there is a lot of star trackers, but obviously they have different payloads. I always wanted to capture deep sky astrophotography, so I needed longer focal lengths with more payload. So there was a few options. I will mention this, and there's the Ioptron star tracker that is very good too, but it was a matter of liking. Let's say a matter of liking. I know that a lot of friends of mine, they have mounts of Skywatcher, and I bought Skywatcher. So nowadays, with an entry level and ultralight equatorial mounts, it made possible for shooting the stars with basic camera gear, actually. And this, it wasn't possible in early 90s, or let's say nowadays technology advanced a lot. So using this equatorial and simple motor, as I said, you can track the stars, which allows narrower apertures and lower ISOs and longer shutter speed. That's why I told you before, you can shoot at 5.6, at f4. It doesn't matter which aperture. If I have, for example, an old Canon lens that it's f4, it's a 40 millimeter. It doesn't matter that much because I'm extending the time exposure. And obviously, if I'm shooting with an f4 lens, it will be more sharper because obviously. So, but using a star tracker, it involves a few technical things to consider. The star tracker, it will not just you put a star tracker and you start shooting. You have to align the star tracker to a particular star. That it is Polaris. So Polaris is the North Star, and is also known. It's a fixed star in the sky. As it makes where's the North Pole, basically. North Star, it's the point around the whole sky, turns basically. Polaris does moves a bit. So when you're pointing to Polaris with the star tracker, you will have this circle over here. Actually, we don't see it moving, Polaris, but it will move correctly with this circle over here. In fact, here I put an image of a star trail pointing at Polaris. All right. So when you align the star tracker with that circle, right? It allows the tracking mount to work well. So if you align it well, it's easy to shoot, for example, a 4-minute exposure or a 5-minute exposure with a 24 millimeter. So you can imagine how much detail you will gather with a 4-minute exposure for example, with 800 ISO, not with a 3200. So that makes a whole different story. That's why I told you that a star tracker, it opened a whole new photography in my life, basically. So these are basically two setups, and I will explain two setups why how I shoot the sky. The left-hand side, it's a simple setup. The star tracker, obviously pointing at Polaris with a DSLR, simple DSLR, and a lens. So you have to keep in mind when you're shooting with a star tracker, obviously you're shooting the stars. So if you're taking a wide field astrophotography, so you're shooting the Milky Way with a foreground, that's a drawback, let's say like that. You will end up with focused stars pinpoint, and obviously the foreground will be all blurred. So I use a technique, it's like compositing or blending, that first I shoot the foreground, then I shoot the stars. I will explain later how I do this. The other setup on the left, on the right, sorry, it's a setup for deep sky astro imaging. So I use basically a 300mm f4 prime lens. So obviously the Lacreta auto-guiding system. It's this camera that I told you before. The auto-guider, it will correct the defects of the star tracker. What I mean by that? What I mean by that is when you're shooting at 24mm or at 17mm, and you're not exactly pinpointed through Polaris or the defects are very small to notice, but on 300mm there will be very obvious defaults, because obviously you're shooting in more in longer focal lengths, and the minor defaults, there are huge defaults. They become huge defaults. So the auto-guider system, what it does, it will lock, I will make it simple, it will lock to a star, particular star, all right, and will continue tracking that star. So when the star tracker has, because it's mechanical, has hits technical defaults, the auto-guiding system send pulses to the star tracker to send it to the right way. So to send it backwards or forwards. So that it's very, very helpful. Let's say with 24mm unguided without this auto-guiding system, I can shoot, let's say, 4 minutes, 5 minutes. But with 300mm, I barely, without the auto-guider, I barely shoot 1 minute. So that's a whole big difference. If I shoot 1 minute without the auto-guider, I will be on the mountains, because it's very difficult. So it's a big help, the auto-guider on those focal lengths. So the Astral Modification, another thing. Basically, what I explained over here, the Astral modification, it can be done on every camera. Every stock camera, it can be astral modified. What it does, what they do to modify it is that the sensor has a filter on it attached. So this filter is called an IR cut filter. So the IR cut filter, his job is that it will correct the spectrum of the colors. But in that way, when the camera corrects the spectrum of the color, the certain wavelengths, it will correct them too. So you can see the potential of those wavelengths that we need to image in astrophotography. And that wavelength particularly is hydrogen alpha. Hydrogen alpha, it's part of all nebulosity, and the nebulosity, basically, it's something interesting. A nebula or nebulosity, it's a giant cloud of dust that is in space. It comes from a dying star. So just a brief. It comes from a dying star, which explodes and throws these elements through space. So something interesting, that certain nebulas like Orion, they are star nurseries, which the gas and the mass itself, by time, it will form new stars. And the gas of the nebula, of nebulosity, they are made mostly of hydrogen and helium. So with this modification, if we remove the IR cut filter, all right, we will bring out more of the hydrogen and the helium in the sky. So that's a quick brief. What is hydrogen alpha and why it's we modify the camera. I use the light pollution filter, the astronomy one. It will clips. It will after the slide, I will continue discussing the filter, and obviously the remote control of the Lacret that's over here. It will correct, and you can see the correction that is doing well. So this is the astronomical filter that I told you before. You can see if the camera, when it will be modified without the filter, it sees all red. If you can see over here, you can see a shot of the Milky Way without the filter. After that, obviously, you can see the other image, how much of the light pollution it removed. Obviously, the final image is processed, but it will leave those glowing over here. These are the hydrogen alpha of the nebulosity over here. The emissions, leave them to pass through. In fact, there's a graph over here. These are the helium and hydrogen alpha. In fact, this filter, it will leave these wavelengths to pass through the sensor. So here, if you can see, these are three images. One, it's blended with the middle one, but here you can see two images, one on the left and obviously one on the middle. A huge big difference between one camera that is stock camera and shot with a tripod, all right, without a star tracker, and the other one with a modified camera and a star tracker. Obviously, these are single files, So these are raw files, not processed. So these are straight from the camera. There is a huge difference. If you can see over here, these nebulosity, they will pop out. Here, obviously, these nebulosity that we can see over here, there is faint. You can see barely nothing over here. But obviously, this was shot with a 200 ISO at 4 minutes. So that's why I told you it will open you a whole different story of photography with a star tracker. And the other one, it's a final image blended on with the same image from the middle. So that's what I was telling you about. So first of all, I'll try, when I shoot these kind of photos, I'll try to make them realistic. So I plan them too, and I'll basically, I will know that I'll try to make it more, I'll be realistic in my images, let's say like that. So I will know that the Milky Way, it will be over here, straight over here. So what I do first, I'll shoot the foreground, and then I'll wait for the Milky Way to shoot it, to exactly put it in the same image that I shot for the foreground. If you can see over here, the horizon, it's slanting due to the rotation of the Earth, because obviously I'm shooting the stars only. And on the other image from the left, because I'm shooting the foreground, the stars are blurred. So that's the technique that one needs to learn to blend if you're using a star tracker. So this is a panorama. This is shot with actually this is shot without the modified camera. So if you can see, that's why I told you I want to be more realistic in my images. When I shot the panorama, you can see the Milky Way, it's here. All right, so I know that finally the Milky Way is going to be straight over here. I shoot the foreground, then I went in front of the rocks, so I don't have any rocks interfere with my image. Then I finally composite my image, final image. These basically, I have to say, still I shoot, you can see in the description, I shoot 30 images and I stack them. So with the star tracker, it will not leave you not to still you're going to have grainy images, but you will have more details, because there's another thing. And while shooting long exposures, the sensor will heat, so the grain will comes more from the heat signature that you're using. If you're shooting for a 4-minute exposure, the sensor of our cameras, the DSLRs, even the mirrorless, even nowadays the mirrorless are pretty awesome. They will heat up. They are not cooled, so that heat signature will still appear. So eventually, still you need to stack your images. These are 2 shots again. These are panoramas. They are horizontally panoramas, because I took foregrounds and then the sky apart, and I blend them. So this is a shot from a non-modified camera. So you can see a whole bunch of difference. So astro imaging, it's a learning curve. It's in every photography, it's a learning curve. So when I started shooting in 2018, I never expected that I will capture or I will learn to edit my images like that. In fact, you can see over here the image from the left. It's straight out of the camera, and there's a big difference to it. So, but I wanted to show you this image because even without modified camera, you can capture a lot of detail. But I will have to say again, the StarTaker, it's a must-have for this kind of shots. This is another image without the stock camera, with the modified camera. So here you can see this. In fact, the image, the one on the left that I showed before, without the filter. So you can see how faint it is, but how much data there is in that image that is faint. In fact, you can see the dust lanes here of the Milky Way popping out. In fact, if you can see the other one over here, it's more detailed, the other one. This one, even the nebulosity over here, it's much more detailed. That's the difference about the modification. And this is shot with 100 ISO at 5.6 with the 50 millimeter. It's a very cheap lens. I wanted to test it, to tell the truth, for 5.6. So it's very sharp, and for 4 minutes. So you can see this one, even here, the nebulosity, it's blown out a bit. So you can see the nebulosity over here, it's perfectly captured. So these are a comparison between stock camera and astro modified camera. You can capture deep sky astrophotos with a stock camera, but you can see here, this is a raw photo and this is a raw photo. You can capture how much hydrogen alpha you can capture with a modified camera. These images are just corrected black points. So from Photoshop, I just corrected the black point. I didn't process nothing in it. So the advantage of a modified astro camera. Another application that I use, this is something different, because I use it as for imaging deep sky astrophotos, not for landscape astrophotos. I don't include the foreground. So when I shoot deep sky, I will know what my target, where it is, with this application that is called Stellarium. I can track my object in the sky, and I use it to star hop, basically, from star to another, so I'll get the exact positioning of the nebula that I want to shoot. These are some summer deep sky objects that you can find in the Milky Way. So the Triffid Nebula, Roifuchs, it's in the constellation of Scorpio, and the Eagle and Omega Nebula. These are found basically in the core of the Milky Way. I have an image that I will show you after where they are found exactly. These are shot with the 300 millimeter, again, with the astro modified camera. These are winter sky objects. In fact, there are some some EXIF over here. The one on the left of Orion Nebula actually was taken with an 80D. So that's why I told you you can use a stock camera to photograph deep sky astrophotos. I use the 80D because I was shooting the Pleiades star cluster, the one on the right, because it's a star cluster and it emits the emission. It's not hydrogen alpha. This is something that I learned recently, because the hydrogen alpha is red. Basically, it's more convenient to photograph it with a stock camera. So after I shot for, I think I shot it for 3 hours, the Pleiades star cluster, there was Orion, and I was tempted to shoot it, and I shot it after that. It took me 2 hours more. So, in fact, I would like to shoot it again this year. And the middle one, it's the Horsehead and Flame Nebula. I shot it for 6 hours. So if you can see, it's 194 images of 3 minutes each. It was shot actually in 2 several days, because the advantage in astrophotography, deep sky astrophotography, you can shoot in 2 different days, and you combined all the data all together. What I use for this, it's stereo sky stacker instead of stereo landscape stacker, and for Windows there's deep sky stacker. They are similar. So this is the advantage. So to bring more data, so you can go shoot today, and obviously the whole week turns out that it would be not good for shooting, and you go the week after, for example, and you combine all the images together with this kind of software. This is where I told you it's the whole year the Milky Way it will appear. In fact, here this is from Stellarium. This is Constellation of Cygnus that appears on the top here, and it's another constellation that winter constellations. Obviously, they are very nice, let's say, and there's a lot of objects that you can photograph. So not the summer Milky Way only. So the core of the Milky Way and the nebulosity in it, but in the winter there is a lot more to shoot. In fact, these are all hydrogen alpha. The emissions that emit hydrogen alpha. This is the constellation of Orion. It's called Bernard's Loop. It's a whole complex. You can find, actually, this is Orion and this is Horsehead Nebula that I showed you before. It's Orion and Horsehead Nebula, these two. But they are in a complex, in a constellation particularly that is called the Orion Molecular Cloud Complex. And you can find this complex between November and December. Shahat, somebody. Hello?
Shahat ħalla xi ħaġa mixawla. All right, it's gone now.
All right.
Complete there.
All right. So these are two raw image files comparison. As I told you before, the one on the right-hand side, it's the Horsehead Nebula, and there's the raw file. So it's with the Astral Modified camera and with the LPS filter, light pollution dedicated astronomy filter. You can see how much is dim in it, but when you stretch the image, the data, it's all over there. The other one on the left-hand side, it's with the stock camera, and it turns out pretty good. Let's say because to Orion, it's one of the most nebulous. It's bright and visible in the night sky. But this is a raw file, the two of them, the raw file, and with processing, actually, it will turns out obviously that's one. I had to stack 194 images more, so it turns out pretty. So another something that I was looking forward to capture. It's I captured the Andromeda Galaxy in last November. The Andromeda Galaxy, it's a spiral galaxy like the Milky Way. It's the nearest galaxy away from our solar system, and it's 2.5 million light years away. So when I just it's very mind-blowing, because when I try to understand 2.5 million light years away, so actually I'm seeing the light when I capture this galaxy. I am recording the light of 2.5 million light years away. So I'm just capturing all the light emissions from this galaxy. So maybe this galaxy, it's already exploded or collided with another galaxy, and we don't know, because actually we're seeing old light from this galaxy. And this is the raw file again on the right hand side, how I captured it and how I processed my final image. It's one of my favorite shots that I shot of deep sky astrophotos, as I really love it. Because mainly it's another galaxy like ours. It's like I'm seeing our galaxy, but in a different kind of perspective. So these are, as I told you before, the Milky Way galaxy, and where you can find these nebulosity. In fact, these are the Lagoon and Triffid Nebula, Orifucius, and Omega, Eagle and the Omega Nebula. And the other way, the winter constellation of Orion, the Orion Nebula over there. In fact, if you can see, when I shot this, the complex, I had when I proceeded, I had to blow out a bit the Orion over here. That's why, because Orion is very bright. I had to push it a little bit more to reveal this hydrogen over here, hydrogen alpha of the constellation. One can shoot, obviously, there's a technique, and you can blend, obviously, a corrected image on that. But I wanted just, it was my first image of Bernard's Loop, because it's called Bernard's Loop, and it was great. But that's why it is blown out a bit, as I needed to actually shoot it again with exposing to Orion. Actually, this took me 3 hours to shoot this this constellation, and it was with 50 millimeter. So if you want to take it further, deep sky astrophotography, there is dedicated cameras. What they does, the dedicated camera, instead of a DSLR or a mirrorless camera, the biggest upgrade, I think, because the sensor is cooled. Here there's a comparison how much grain you will get from heat signature. Actually, because obviously the astronomy camera is cooled from one frame. Imagine that's cropped 100%. So there's nothing in it. It's incredible, because obviously the cooling is at a point of 45 degrees Celsius. So the sensor itself, it will never heat up. It has a set point in it that will calibrate the frames with the cooling. Obviously, with DSLR, you cannot do that. There is modifications. You can make a per tier cooler in it, but will never turn up as an astronomy dedicated camera, especially because it's dedicated for the things. And the drawback of a dedicated camera is that obviously it's not a standalone camera that is like a DSLR, but you need to connect it through a laptop. So for me, it's like a baggage, a little bit of baggage, if you don't have a setup that it's on your roof or something that you just go over there and you stay comfortable and shoot from your roof. In fact, I wanted to show you this. This is a friend of mine, it's Gert Catania. This shot of the Eagle Nebula. So I will turn the Eagle Nebula is this over here, all right? And the Eagle Nebula is the one on the top. He took it with his telescope, and you can see this is a single image from a dedicated astronomy camera, obviously with a dedicated professionally telescope and a dedicated mount. It's with a Celestron AVX tracking mount. The telescope is Schmidt Cassegrain, and with a focal length of 1400. So with a single frame, you can see how much difference. This is shot from his roof, and he just borrowed me this image to show you in this presentation. It's amazing. In fact, this is the Eagle Nebula, but in the Eagle Nebula there is another nebulosity that is called Pillars of Creation. These are some other celestial events. This is the one on the left. It was taken in this last December. There were a conjunction. This is a composite image, by the way. This is there's Jupiter and Saturn over there. You can see how much close they are. I took it with a 300 millimeter to expose the planets, and then I shot my shot myself with the 24 millimeter, and then I composed everything together. This is in July, a comet Neowise, shot back in. It was a rare cosmic event, and the other one on the left hand side, some aurora borealis from Iceland. When it was an amazing trip. I recommend to everyone to go once in their lifetimes to Iceland. It's amazing. And this is a lunar transit, a lunar eclipse back in 2018. You can see the shadow of the moon casting over here. This is called the penumbra, and this is called the umbra. What they are mean, because when the shadow casts, you will turn up with the dark side of the moon, because obviously the sun, it will be reflecting the shadow of the sun on the moon. And this is the sequence on the left from start to the beginning. This is, I shot the foreground, and basically I set up my camera with the intervalometer, and every 5 minutes it took a photo of the moon rising up, and I composite them myself in one photo. Thank you very much again for this opportunity. I hope you really enjoyed it. Looking forward to see your Milky Way shots.